Hi everyone, this is a Math 082 video. This is 1.3. So in this video, I will be defining the slope and teaching you how to identify the slope of a line given the graph of the line. I will not be covering vertical and horizontal lines in this video. That will be covered in a separate video. And number 3, using the slope equation, I will not be covering that in this video as well. So I always encourage my students to think about what is slope. So the nice thing about this concept is that it's easily relatable to everyday life. So if you think about driving or walking or running, you can imagine yourself running uphill or running downhill or maybe even running just on a flat surface. And we have a sense that the steeper a slope is, the more energy it would take to run up. And the shallower it is, or the flatter it is, the less energy it would take. So, what is slope telling us? It tells us how steep or shallow is a line. And it also tells us whether our line is going up, like in this example where I'm running uphill, that would give us a positive slope. Or whether we're running downhill, which would mean that we have a negative slope. And to determine whether it's positive or negative, we always move from left to right, just like we read from left to right. So in your academic career, you might have seen several definitions of slope. So we generally use the letter M to represent slope. Some people speculate that this came from the French verb monter, which means to climb. Slope is also defined as rise over run, or the change in y over the change in x. Math people, we really like shortcuts and simplifying things, so we often use this little triangle symbol, the Greek letter delta, to represent the change in y. We also have a slope formula, which I'll cover in more detail in a later video, which is y2 minus y1 over x2 minus x1. So let's get started and look at some graphs and practice identifying their slope. So this is straight from the 082 textbook. So I always encourage my students, before you actually find the slope, ask yourself, is the slope positive or negative? So again, to answer that question, we always move from left to right. So use your imagination, pretend you're a person standing here. If you're moving from left to right, are you running uphill or downhill? So hopefully you said uphill, which means that you have a positive slope. Okay, how about this next one? If you're going this way, are you going uphill or downhill? Again, you're going uphill, so it's positive. I'm going to skip this because I'm covering vertical lines in a later chapter. So let's look at number 4. Again, moving from left to right, are we going uphill or downhill? So that's clearly going downhill, so we have a negative slope. So now that we feel comfortable identifying positive and negative slopes, we can actually get down to the part where we find the value of our slope, whether it's positive or negative. So let's look at this first problem. Okay, so again, I'm going to be using the definition of the change in y over the change in x throughout this entire video. So notice you can find either one first, as long as you put them on the right spot. Okay, where should I start? Does it matter which point I start and which point I end at? The truth is, it doesn't matter. So let's try both ways. First, I'm going to start at this point. To find my delta y, I'm going to go up 1, 2, 3, 4, 5, 6 units. So that means that the change in y was positive 6. Let's see if we can find our change in x. So to find our change in x, this time we go over 4 units to the right. Remember that when we move to the right on our x-axis, that is a positive direction. And we move to the left, that would be a negative direction. Likewise, on our y-axis, if I move up, that indicates a positive direction. And when we move down on our y-axis, that's a negative direction. So far, both my delta x and my delta y are positive. So I can put those together. Delta y over delta x is equal to 6 over 4. And in this class, you're expected to always reduce fractions. So I'm going to reduce that to 3 over 2. Now, in previous math courses, you might have learned to express 3/2 as a mixed number, like 1.5, or as a decimal, like 1.5. However, for our purposes, we do not use mixed numbers or decimals. We want to leave our slope as an improper fraction. So let's explore this idea of starting from a different point. What if I had decided to start from this point up here and go down 6 units? If I had done that, my change in y would be -6. Likewise, I would then have to move 4 units to the left, and my delta x would be -4. Let's put those two values together and find out if that still gives us the same answer. So that would give us a delta y over delta x of -6 over -4. Well, guess what? That still reduces to 3/2. So we've just proven to ourselves it doesn't matter where we start and where we end. As far as finding our slope, we're still going to get the same ratio of our change in y over our change in x. Let's look at this next graph here. So this time, I'm going to find my delta x first. Again, it doesn't matter as long as you put it in the right spot. Okay, my delta x is a +1 because I moved to the right. Then I need to go up 1, 2, 3, 4, 5 units. So then my delta y would be +5. When I put those together, I find that delta y over delta x is +5 over +1, or just 5. Okay, let's say I had thought about doing the other way. Let's say I had thought about going to the left 1 unit, and then going down 5 units, which would give me a delta x of -1 and a delta y of -5. Would that still give us the same exact slope? Well, let's see. Oops. Oh, good grief. Okay, so delta y is -5, delta x is -1. Okay, it still reduces to 5. Okay, so again, it doesn't matter which point you start at and which point you end at. You're still going to get the same ratio. Let's do one more example, and then we'll end this video. So this next one, we are going to start at this point. Let's say I find my delta x first, and I find that my delta x is +2. And then from here, I can go down, and that means that my delta y is -1. Let's put those two things together. So then I have my delta y, -1, over +2, which is just -1/2. Now, again, let's imagine that I had thought of starting at the second point and going left 2, so that I had a delta x of -2. And then let's say I had thought of going up and getting a delta y of +1. Would that still give us the same slope? Well, let's see. We have delta y over delta x. That's 1 over -2. That's still exactly the same slope. It's still -1/2. Stay tuned for more videos.